Here's a video discussing the beginning of chapter 2 notes, and we're going to focus on 2.1, 2.2, and 2.3. They're actually not labeled like that, but they will correspond to the homework labeled in that way. So we'll definitely go more in depth next time we meet as a class. Let's just define a relation and a function. So a relation is when you're relating input with output values, or basically x and y. So any equation is considered a relationship, like y equals x or y equals x squared. You're just describing how these two variables are related. Um, I mean, this is kind of interesting, like class periods and teachers. So myself, for example, um, if you put like teachers in one column, so Mr. E, and period in another column, we have 7 periods at the school. And I know I'm teaching ADFG. So you'd map it like that. So you can think of this as like the input and that as output. I mean, of course, we tend to use numbers for this stuff, but here I'm just using like a real life example. Or days of the week in TV shows, like what TV shows show up on certain days of the week. I mean, that's more on real TV, not the streaming. Streaming can watch whatever you want. But the input values is called the domain. That's basically X. The output values are called the range. That's Y. Now, a function is a relation in such a way where for each input is exactly one output. And that's where we're going to talk about the vertical line test. We'll have that discussion next time as a class. But a relation will pass the vertical line test if it doesn't touch the graph of more than one place. Then it'll be a function. And we'll have that discussion when we go over this as a class next time. We'll also talk about other types of functions like linear functions, which are lines, absolute value, which we've been talking about already. Quadratic we'll talk about later. Polynomial, I don't think we'll get to this summer. Exponential we won't get to this summer, but D&E you'll definitely see in Algebra 2. But we'll still evaluate them and work them out because they're not too hard to do. How to find the x-intercept from an equation. That's when you plug in y for 0. Actually, let me erase that. Plug in y equals 0. You solve for x. That's not that hard. Do the opposite over here. If you want the y-intercept, you plug in 0 for x. And we'll do that for these problems down below when we meet again as a class. Linear function is just a line. And we'll have discussions about slope and y-intercept. Slope is a rate of change, or the change in y, rate of change in x. So that's when you have a consistent change between those two values. That's what makes it a line. And different forms, y equals mx plus b. And point slope will be this. That's actually a preferred way of writing it, of writing a line. Even though you might be more accustomed to y equals mx plus b, point slope form, especially as we move on to calculus, is going to be the preferred form. We'll talk about graphing these lines, which shouldn't be too hard. For example, paragraph number 1. If you recognize the fact that -4, comma 2 is a point of the graph, because remember it's y minus y1 equals m times x minus x1. So x1 is -4, y1 is 2. So -4, comma 2. Slope is 2/3, go up 2 over 3. And you draw a line to those 2 points. So you identify x1 and y1 from the point slope form, and then use the slope, which is change y over change in x. You go up to right 3 because they're both positive. Now, if there's a negative on front, I usually will tend to go down 2 and then right 3. So I'll always go right, but I'll go down if it's negative, and up of course, is positive. And some other ones we'll graph as well. And if we have some time, maybe we can move a little further with chapter 2. We'll see how things go tomorrow. But definitely have a lot of problems to work through. If you look at 2.1, they'll have all the stuff in functions. That's pretty fast. Slope and rate of change we'll talk about. And parallel and perpendicular lines, which notes didn't discuss, but we'll talk about in class. 8 and 9 are kind of tricky problems, but are good to do. And then of course we'll graph equations and we'll go over other stuff here. And then we'll probably go back and look at the leftover problems from chapter 1, which we haven't done yet. Some of the challenge problems I think are good, just to kind of reinforce the skills from the previous chapter. All right, very short video, and I think we're all done.